the different applications like gas suppression systems, also in working with detection systems. Where do we use the gas suppression systems? We can use the gas suppression systems in any kind of fire situation, but we have limitations of these systems because of their high budget, and we cannot use them everywhere because of some physical restrictions. But for the fires types, class A, class B, and class C fires in general, we can use these gas systems. So we have a fire triangle that consists oxygen, energy, and chain reaction, and the combustible material. And this fire triangle is also used to our the fire extinguishing mechanisms. One of these items will be critical for us to define our fire protection system. So when we use inert gas like argon, nitrogen, or their mixes, or CO2, we are trying to reduce the oxygen volume, oxygen rate inside the room or area below 13.6%. So when this happens, we don't have enough oxygen for the chemical reaction of fire. So we can avoid fire, or after fire starts, we can stop the fire by reducing the oxygen by using inert gases and CO2. And we have the other gases like FK5112, which is NOVEC 1230, and HFC227EA, like FM200. So these are also chemical gases, which are not inert gases. So we are using here, absorbing a lot of energy from the room, like refrigerating, cooling gases. So we are discharging these gases inside the room, and we are removing a lot of energy from the room. So the fire stops. And some other kind of gases which are currently banned, and it's forbidden to use these gases, were focusing on the chain reaction, and they were breaking the chain reaction, but they are harmful to the environment, so they are not allowed to use right now. So we use either inert gases and CO2, or the chemical gases that we call halocarbons or halochemicals. A typical gas system has cylinders and a pipe system and nozzles. And the cylinder has some portion of, at liquid phase in general, the extinguishing agent. This is in general liquid, but sometimes in gas. For the chemical systems, the halocarbon systems, which has cooling effect, they are in cylinders in liquid condition. And we have on top of the liquid, we have the nitrogen to pressurize this extinguishing agent and direct to the room with pressure. And there is an electric release unit. When detectors gives a signal to the panel, the electric release unit is energized by the control panel, and the system activates and the gas is discharged. We still need here a detection system to operate this system. Let's see how a gas system works. This is a chemical gas system for protection of, for example, two rooms. One is a server room that has a lot of valuable devices, very expensive devices, and the data stored inside them, very important, and we cannot use water in that room. And the other zone 2 is the archive room, very important papers, and also here we cannot use our water systems in order to not damage important papers. So we have a room with the extinguishing system fixed with pipes and directional valves, each servicing to a single room. And when you see in the largest zone, we have detectors detected the fire with smoke, and it sends a signal to the panel. And the signal is also used to actuate the pilot valve, which is operating the other valves in the system. And by knowing that the first zone has the fire, we are activating the first zone activation solenoid. Or if zone 2 is activated, then the zone 2 solenoid is activated. So the detectors will decide which zone should be activated. In this case, this is zone 1, and the selector valve is opening, and or otherwise, if the zone 1 instead of zone 1, if the zone 2 gives an alarm, the zone 2 valve opens. When the zone 1 opens, the gas from the system is actuated by another pilot system, and it discharges just necessary amount of gas from the necessary number of cylinders. These are the main cylinders for the bigger room, zone 1, and the gas is going to the related zone 1. Or otherwise, if it was zone 2, the related pilot line activates the necessary number of cylinders, which is this time not 3 but 1, because it's a very small room. So it sends all the gas from one cylinder to the room automatically. And as you see now, the zone 1, the gas is discharged to the room and controls the fire. Or otherwise, if it's zone 2, it's only one nozzle and one cylinder. It's a very small room. It discharges the room in 10 seconds, and it controls the fire.